Good day, everyone. We are to quickly simplify this problem. We are to simplify logarithm of 256 base 4. Now, in one of my videos, I've treated how to change from uh, indices to logarithm and logarithm to indices. And that is what we are going to be using to solve this problem. Now, let us look at this, everybody. Let's say we have, if b n, if n is equals to b raised to the power of x, that means the logarithm of n, the logarithm of this n to this base b will be equals to x. So this is indices form and this is logarithm form. So you can check the two now. If we are having logarithm form, then we can change to indices form. That is exactly what I'm trying to say. But then if you check this logarithm form, you will see that it is very similar to the question we are given. That is, this 256 is standing for our n, and this 4 is standing for our base, which is b. Why this x is our answer, which is the logarithm itself. Now, but in this question now, we don't know the answer yet, and that is why they asked us to simplify this. So we can think of our answer as a variable we can pick any variable to represent our answer and then change to this indices form, and then we can complete and solve the problem. So what am I trying to say? What I'm trying to say is that we are going to say let logarithm of 256 base what? Base 4 equals to x. Because we know that we must have the answer, and this our answer is actually this x. Do you understand? Good. Then it remains to change from this logarithm form to this indices form. From this logarithm form to this indices form here. So how do we change? We can check here for the change. So now we can easily say, after you might have said, let logarithm of 256 base 4 be equals to x. That is, you are saying, let the answer be x. And that's exactly what you are saying. So this is one of the methods of solving this problem. Had it been we have talked about the the laws of logarithm, we could have solved this problem in another way. So we have only dealt with how to change from, that is the relationship between indices and logarithm, and that's why we are trying to solve it this way. So this is the step you will take whenever you see such question also. That is, if you are trying to solve it this way. So what are we going to say? We are going to say that is the number which is the number which is 256 now will be equals to 4, which is the base. You're going to write the 4, right? And the logarithm, which is that x, will be the power here. So that is how to change it to indices form. Now, I haven't changed it like that. That means the problem has completely left the logarithm form now, that it is now in indices form. So everybody should know how to deal with this indices form. Everybody should know how to deal with this. Now, if you want to deal with this now in indices, you remember one of the ways this has turned to equation involving indices. So, and what we normally do in equation involving indices is that we try to make the base on either side of the equation to be equal. So, and what I do say is that any number which is a base, remember this 256 is raised to power 1, and we don't need to write the 1. So now, any number that is not a prime number, please try to break it down, because I always talk about indices as breaking down. So the next thing is that this 256, how do we break it down? Some people might still be thinking of what does it mean by breaking down? Well, let me quickly do that. So we are saying that 256, for example, we can say, if we want to break it down like this, so 2 can go, right? Because it's an even number. So meaning that 2 in 2 is going to give us 1. 2 in 5 is going to give us 2. It's remain 1. Put it here, making what? 16. So 2 in 16 is going to give us what? 8. So 2 can still go. So 2 in 12 now. We're going to say 2 in 12. So 2 in 12 is going to give us 6. 2 in 8 is going to give us what? It's going to give us 4. Of course, we know that 2 in 1 cannot go, and that's why we said 2 in 12. Remember that. So now, we use 2 now again, because it's still an even number. So 2 in 6 is going to give us what? 3. And 2 in 4 is going to give us 2. Of course, 2 can still go. So 2 in 3 is what? Is 1. Remainder 1, put it here, making 12. 2 in 12 is going to give us what? 6. 2 can still go. 2 in 1 is not possible. So 2 in 16 is what? Is 8. So 2 can still go. 2 in 8 is going to give us what? It's going to give us 4. And 2 in 4 is going to give us what? 2 in 4 is going to give us 2. And 2 in 2 is going to give us 1. So let's count it. 1, 2, 3, 4, 5, 6, 7, 8. So meaning that, the meaning is that 256 is actually 2 raised to the power of 8. 2 raised to the power of what? 2 raised to the power of 8. 2 8 times. So I can easily write that this 256 here, I'm going to write it as what? I'm going to write it as 2 raised to the power of what? Raised to the power of 8. Oh, let me write this 8 properly. 2 raised to the power of what? 2 raised to the power of 8. Then is equals to. Now, what about this 4? Well, this 4 can still be broken down, because this 4 is not a prime number. At least, like, the base must be a prime number, so that you will not be able to, you'll not be able to break it down again. So this 4 now, we are also going to break down 4. Remember, if we are going to break down 4, it's still like this. 2 in 4 is going to give us 2. 2 in 2 is going to give us 1. And that is what we are trying to say, that 4, we are going to break down 4 as well. So if you break down 4, what you are going to get is actually 2 raised to the power of what? 2 raised to the power of 2. But don't forget that the 4 has a power before, which is x. So you put that one in brackets, and then you close the bracket like this. Then the next thing is that now, to solve equation involving indices, so what we normally do is that once you have made the base on either side of the equation to be the same thing, then the next thing is that, look at this base now. This base is 2 here, it's also 2 here. Now, once the base are the same, then we just equate their power. We equate their power. That's the next thing. That's how to solve equation involving indices, and I've done some videos on that. So that means 8, we are going to equate the power because the base are already the same. So which is equals to 2 raised to open bracket what? X. So we close the bracket. So meaning that we're going to say 8 is equals to 2 bracket x, means 2 times x, which is what? 2x. And remember, I can write 2x, I can write the 2x on this side equals to 8. It did not change anything. It's just like you are saying, 4 equals to 2 plus 2. And you now decide to say 2 plus 2 equals to 4. Does it change anything? Of course, no. Of course not. It doesn't. So meaning that you can decide to write it like this. And remember that we are trying to look for x, not, we are looking for the x. We are looking for the x. We are not looking for 2x. So meaning that we are going to say 2x, we are going to divide both sides by what is disturbing our x. So say 2x divided by 2 is equals to 8 divided by 2. So this cancel this, and then our x eventually is going to be 2 in 2, 1, 2 in 8 is what? 4. So our x is going to be 4. And that is the logarithm. That is the answer to this question. Thank you.